Graphing linear inequalities in two variables. Not only can your calculator graph functions in two variables or equations in two variables when you can solve for one of the variables, it turns out that it can also graph the linear inequalities that we need to deal with. And it does so by graphing the line associated with the inequality and then shading to one side or the other. Let's see how that works. So if we take a look at example 1 here, we're asked to graph the linear inequality 2x plus 3y is less than or equal to 9. Now before we can graph any kind of line or linear inequality, we first need to solve for y, as we kind of get it into slope-intercept form. And in this case, when we do that, we end up with y is less than or equal to negative 2/3 x plus 3. So let's go into our calculator and let's graph that line. So we'll press the y equals key. And we can enter negative. And then I'm going to put the fraction in parentheses the way I always do, just to make sure that I'm very careful with order of operations. And that's negative 2/3 times x. And then to that we're going to add 3. Alright, once we have that in there, we'll press enter. And then what we're going to do is we're going to cursor back up to the entry line where we've just put our function. And we're going to cursor to the left until we're sitting here and we have that symbol at the left, kind of that diagonal line flashing. And what we can do once we're there is we can press the enter key and that'll change it. We go from a regular line to a thick line to shading above to shading below to a special graphing mode that we haven't previously discussed, another graphing mode, a dashed line if we want one, and then back to our regular line. So in this case, we have y is less than or equal to negative 2/3 x plus 3. The equal to part tells us we're interested in points on the line. The less than part tells us that we're interested in points under the line. So we want to press the enter key now until we get to the shading below the line here. Alright, so this is now going to shade underneath the line when we graph. I'm going to do this in a standard window, so I'm going to press zoom and 6, and then let the calculator go ahead and graph. And it will graph both the line and it will do the shading at the same time. Now, while it's doing this, I will point out that one of the things you need to be careful about is the calculator, when you're doing the shading, is always going to graph the line as a solid line. And we know that we need to graph a solid line when we have less than or equal to or greater than or equal to, but it's a dashed or dotted line when we do greater than or less than without the equal to part. The calculator won't give us quite that much distinction, but if you have to draw this on paper, please make sure that you're aware of that and careful with that. All right, so there's a nice picture of the inequality y is less than or equal to negative 2/3 x plus 3. Any point on the line or any point under the line satisfies the inequality and is therefore part of our solution set. In example 2, what we're going to do is look at a system of two linear inequalities, and we're going to graph them and look for the intersection of the graph. Alright, so I've already done the work here of taking these two given linear inequalities and putting them into that slope-intercept form, or solving for y, if you like to think of it that way. So let's go ahead and put these both into the y equals menu and then graph. So we'll press y equals. The first thing I'm going to do is clear out the first one. And in this case, I want y less than 3x minus 8. So I type in 3x minus 8. And I press enter. And in this case, I want to shade below that line because this is less than, and we're already set up to shade below from the previous example. So now let's enter the second inequality. In this case, we're going to graph negative, and then in parentheses 2 divided by 3 for 2/3 x plus 2. And in this case, because of the greater than or equal to, we want to shade above. So I'm going to press enter, and I'm going to cursor back up 1 and to the left 2. And once I'm on that very leftmost character, which tells me what kind of graph I've got, I'm going to press the enter key until I get the shade above symbol, just like that. I'm going to leave the standard window that we used previously, and I'm going to press graph. Now this will graph the first line, 3x minus 8, and it will shade below it. If you're doing this on paper, the line part would be a dashed line because points on the line are not part of our solution set, only points under it. And now it's going to graph the second inequality, y is greater than or equal to negative 2/3 x plus 2. In this case, this would be a solid line if you were graphing it on paper, and would be interested in points both above, points on the line, and points above the line. You'll notice when it shaded the first inequality, it used vertical lines. Shading the second inequality, it's using horizontal lines. And it's fairly clear to see where the overlap area is. Alright, this clear area out here to the left, points in that area satisfy neither of the inequalities. Points above where we only have the horizontal line satisfy the second inequality only. Points toward the bottom that have the vertical line satisfy the first inequality only. And points here kind of on this right hand side where we have both vertical and horizontal lines satisfy both of the inequalities. So that's where our solution set is. And this extends outward to infinity in these directions. It's not limited to just what we see on the screen. Now, I'd like to point out that sometimes when you're doing things on the calculator, it's easier to work here and see things in an open area than it is in the overlap area. So sometimes what you want to do is go into the y equals menu, and you actually want to shade opposite so that the shaded part isn't part of the solution and the unshaded part is part of the solution. So I'm going to change this first one to shade above, telling it to shade where where the points don't satisfy the inequality. And I'm going to change the second one to shade below. Alright, so now we're shading opposite. So our solution set, graphing this way, will now be the area that isn't shaded by either of the inequalities. And again, sometimes it's just a little bit easier for visual things, especially if you need to graph more than just two inequalities at the same time. It can get very confusing and very cluttered on the screen since we're dealing only with black and white on the calculator. All right, so as this finishes graphing here, now where we saw just white before, we now see the double shading. Those are points that don't satisfy either equation. Where we see the white now, those are points that satisfy both equations. So be conscious of how you're choosing to do this. There's not a correct way. There's not really a right or a wrong way to do it. Just make sure that you do it consistently however you do it. Make sure that you graph everything as they're supposed to be graphed or everything opposite. And make sure you know which part of the screen you're looking at when you do either one so that you find the appropriate solution area. Alright, one last example here, example 3. In this case, we're going to graph a system of linear inequalities. This has a total of 4 linear inequalities, but if you look at the last two, we're told that x is non-negative and y is non-negative. That is, they are both going to be greater than or equal to 0. And that tells us that we're graphing in the first quadrant. So what we're going to do is we're going to enter the other two inequalities. But then when we go to before we graph, we're going to use the window to restrict ourselves to just the first quadrant. And that's kind of how we'll get at that idea. You can actually get the calculator to graph y equal to 0 and then shade it appropriately. But it's a little bit more difficult to shade the x greater than or equal to part. X greater than or equal to 0 part, excuse me. So let's go back into our y equals menu. And let's clear out the first function and replace it with negative 2x plus 5. And I'll press enter. And then I'm going to clear out the second linear function here. And we're going to type in our new one, negative, and then in parentheses I'm going to put 1 divided by 3, and that's going to be times x plus 2. And I'm going to press enter. And then I'm going to go up and make sure that I'm shading appropriately. And what I'm going to do is I'm going to tell it to shade the opposite. So the first one says I want things greater than or equal to. I'm going to shade below. I'm going to shade the points that don't work. And the second one asks me to shade below. I want things less than that, so I'm going to shade opposite and shade above. In other words, I'm going to shade the points that don't work. So I need to press the enter key a couple times here to get around. And there we go. So now I'm doing a shade opposite. So what I'm looking for when I'm done is the clear part of the screen. That's where my solution area is going to be. Now I said before, because of the last two inequalities, we want just the first quadrant. So I'm going to change x min to 0. That's going to give me x greater than or equal to 0. And I'm also going to change y min to 0. And that will make sure that y is greater than or equal to 0. And then I'm going to graph. So there's my first inequality, shading the points that don't work, that don't make the inequality true, or don't satisfy it. And then we'll wait for the second one to come in here. It is also shading the points that don't work, the ones that don't make the inequality true. Alright, so what we're looking for when we're all done is the portion of the screen that is not shaded here in the first quadrant. So we get this triangle down here toward the bottom. It's not very big. We could change our window to look at it a little bit more closely. But that right there is what we are interested in. Those points in that triangle satisfy all of these four linear inequalities at the same time.